Hello, everyone. My name is Chris Berg. I run DataKitchen here in Massachusetts. I'd like to welcome you to today's webinar. Um, so just a few housekeeping things before the meeting. So those of you who are actual real persons and not AI bots, thank you for joining us. I will share the recording and slides after the meeting. Put your questions in the chat window during the meeting. I'll answer your questions when I can, or I'll certainly answer them at the end. And we've targeted about 45 minutes. It turns out I have a lot of slides, so it may take a while. That's what we'll do. So you'll get the slides at the end, ask some questions. I'll try to answer them when I go. And for those of you in person, thanks for being here in person. Not that there's anything wrong with AI note takers. So we've got a 5-part agenda. So we're going to talk a little bit about data products and a little bit about DataKitchen, our sort of background and motivation on this topic, and some perspectives on data engineering. Then we're going to talk about this data architecture pattern that we've used for over a decade. So I guess it's not new. It's called functional, idempotent, tested, and two-stage. And then we'll talk about some patterns on how to get fit. Starting with data products, I asked ChatGPT what a data product was, and it gave this answer that it's a thing. It's a reusable, trusted, well-defined data set that's designed and built and managed like a product. And so I think a lot of the discussions around the concept of a data product is its thingness. What is it? What's it made of? But I don't believe that. I actually think data products are a how and not a what. They're a method and not sort of a list of components. I went to a conference and heard 2 people debate for an hour what the right component list is of data products. And I just think that's absurd. The whole point of a product is to deliver value to your customer in an iterative way. And it's the product's about the outcome, not the method. And it really can be anything. And so I think the idea of data products is that it's not a project. So it doesn't have a start and an end. It doesn't have a waterfall. It's focused on the flow of work to the customer. And so this, instead of being focused internally on what your steps are, it's focused externally and focusing on the flow of value. And I think that's really important, both for the architecture talk that we're going to have today and data products. And in another aspect of a project or data projects is that, you've got tasks and they're sort of assigned to you, right? People are sort of brought to work. But on the other hand, you're trying to have work brought to the people, like your customers are asking for these things. And of course, a project tends to be waterfall. A product tends to be iterative and have lots of sort of irons in the fire. And, one way to think of a data product, and if you look at this diagram, it's pretty typical. It's got sources on the left, process technology and organization, and customers on the right. And then there's this idea of I have some work and I'm going to do a whole bunch of development, modeling, testing, building, and then I'm going to deliver it sort of monolithic. But I'm following my project things. I've got my documentation. And I think data products are much more iterative. They are focused on delivering little bits of value and continually improving. And so they're really never done, right? It's sort of about releasing insight quicker. And I think the other thing about data products that's incredibly important, and I'm going to mention this again, is that it helps you realize exactly what your customers want. And so this notion of flow is really important, and it's the flow of value. And what is value in a data and analytics system? Well, it could be new data. It could be improved data. It could be a new model, a new visualization. And that's all sort of measured as code and configuration, right? And I think it's also trust. You can have a new data set, but if your customer doesn't trust it. And how do you measure this flow? Well, it's cycle time, which is how long it takes to bring something from the brain of your data engineer or scientist into production or into your customer's hand. It's how fast you can, or what the success rates of deployment. And I think I would add to that the success rates of quality, since the data is always changing, and then the work done. And so if you read that Mick Kirkstone book about projects to products, I think that encompasses my view of what data products are. And so now I'm going to switch to a slightly different topic than this idea of data products. I'm going to talk about sort of our company and our background and motivation. So I've been working in technical fields for 35 years and data fields for 20. Both as an individual contributor and manage lots of data engineers and data scientists, et cetera. And I've learned kind of three things. You're going to get crappy data and stuff's going to break. Your customers don't know what they want until they see it. And you always have too much to do. And for the last dozen years, my co-founders and employees and I have really focused on trying to fix this problem called data ops. And we've written books on it and talked on it sort of through the roof. And data ops focuses on the idea that there's sort of two processes that you have to focus on. One is your assembly line. Your data product has to be manufactured. That's what we call it, the value pipeline. And then the other one is that your data product has to be changed, the innovation pipeline. And so, we think that the goals of these things are that when you have an assembly line, you want to decrease production errors. So in production, and then you want to also be able to increase the cycle time and the success rate of putting things into production. And the result of that is you just get a lot more productivity. So that's sort of thinking in a managerial way to think about data ops. But also, we are a profitable company. We're owned by our sort of founders and employees. And so we've been in independent business for about 12 years. And partly what makes us independent is we sell our software, but we also deliver data products following data op principles using the FITT architecture with all our customers. And we've got these great results. And so to me, one of the reasons I'm talking about this architecture now is, we've written a lot about data ops. We've written a lot about data quality. We have open source, but we haven't talked too much about this architecture pattern. And so one of the things I constantly wonder is why it's not common for people to follow these principles. And perhaps the FITT data architecture is a way that can make it easy. So that's why we're talking about it. So lastly, what are, given all these perspectives or our background, what's our perspective on data engineering? So the first thing is that so if you look at the entire cost of delivering value to your customer, you add up all your costs over a year for a data engineering team, or this I think applies also to data engineering team that have analysts, any sort of data and analytics team. The cost of the people is much greater than the cost of the stuff that people work on. And lately that's shifted to, more towards compute than storage. At other times it would have been more storage than compute, given there's a lot of Snowflake and Databricks customers out there. But I think this is really true. And in my experience, this ratio is off. It's often like 80 or 90% people and less compute. But Snowflake's getting expensive. But unfortunately, if you look at that, the amount of time that people spend, the amount of is really unproductive. And that means they're doing work that they don't need to be done. They're fixing and delivering errors. They're firefighting. They're doing wasteful tasks. And this is backed up by Gartner, other analysts, research that we've done. And this sort of, I think, as a consequence, I think everybody who works in data sort of knows that we're doing a lot of stuff that really doesn't matter. And so the second idea is that from our background is that maximizing flow, trying to focus on the productivity of the people, trying to make it easy for them to do work, lowering their cognitive overhead, making things really apparent and simple is a very important principle. And then every data process, whether it looks like this one, is complicated, and errors can happen everywhere. Like they could be in the raw data, they could be in the integrated data, they could show up. That could all be perfect, and your Tableau server could fall over, or your export could break. All these things could happen. And then The last idea, or the second to last idea, is that the processes acting on data. So this is things like the code, the transformation process, the prediction, the reporting, are actually much more important than the data. And so this is a very almost philosophical argument, but it's sort of bounded in the sense that, like, we really work in a system as a team, and that in making that system better, the tools, the techniques, actually drives productivity. And so in some ways, the process is much more important than the data, which may be upsetting to a lot of data people. But it's kind of bounded in this sense that, there's a person who changed my management and my leadership I read about 15, 16 years ago, Deming, who talked about that. It's when you have a problem, 98% of the time, it's the system and not the person. And that system, Elon Musk calls the machine that makes the machine. It's a factory. And there's a quote from Satya Nadella: if you've got a choice between a developer working on a feature or working on productivity, always choose productivity. And so trying to emphasize the productivity of your team, and that productivity, I have a very contrarian view. It's not the amount of time. Since there's so much waste in the system, so much time here with errors and operational, this is the stuff that you have to focus on. Using your LLM to create new code, again, isn't going to get you the lift of focusing on things like errors and operational tasks. And so in some ways, this idea of a FITT architecture is in response to that, our view of data products, our background, and our perspective on data engineering. And so let me stop there. And that's all sort of a 12-minute introduction to how we think about the world. And so now we're going to get into what is the FITT architecture. And so the FITT word stands for functional, idempotent, tested, and two-stage. And we're going to talk in this presentation about what those mean. And so the first thing, FITT it's not new. It's in some ways functional programming, as opposed to object-oriented programming, has been around for decades. Idempotency has been around forever, right? It's just a fancy name you do it again, you get the same thing. And testing obviously has been around, and two-stage data architecture. So this is nothing new. It's just taking some of these ideas and mapping them onto data and analytics systems. In fact, mostly everything in data and analytics isn't new. It's showed up somewhere else. You can sort of pick your favorite buzzword. It's got a heritage in manufacturing or software engineering these days. And FITT is really designed to maximize flow and minimize errors. And for flow, you could use the term productivity. You could talk about what it specifically means is the ideas that originate in your team's head getting into the hands of your customer. That's really the flow that we're talking about. And so how fast and quick, and then minimizing errors, both in deployment and running in production with crappy data. And so we've used this is where we've used it. It could work in other cases, but this is our experience. So I'm sort of caveating what we talk about. So your data size isn't too massive, like under 100 terabyte-ish, with kind of updates that are smaller than that. So I haven't worked on petascale databases. I would imagine this works, but haven't tried it. So your data updates and refreshes kind of happen every hour or every day. It's sort of not streaming. And you're doing kind of serious data integration work. There's a lot of work that has to be done in the data to make it useful for your customers. You could build schemas, joins, one big table, predictive models, all that stuff. And then it really shines when your business stakeholders, when your customers, they keep asking for changes because, of course, they're always going to do that. And, of course, your customers really want to trust the data. And this has just come out of our history of who we've, the kind of customers that we've got in our consulting practice. So I'm going to go through now sort of the four parts to it. And so functions, everybody knows what a function is. You took algebra when you were a kid and you talked about the function machine. You got some stuff that goes in, you get some stuff that comes out, right? And so the idea here is there's no hidden state or no mysterious dependencies in it. They're kind of pure. Stuff comes in, stuff comes out, but there's nothing happens way over somewhere else. And it's sort of clearly definable inputs and outputs. And then second, idempotency. Think of it as running a data pipeline multiple times where the same input will always produce the same output. And so that's sort of hard, right? If you've got a pipeline that adds 2 to an integer column, well, you run it again, you're gonna add 2 again. And so it's not idempotent. It's not going to produce the same output. And that's the point of a database in some ways. But when you run things that are idempotent, your recovery becomes trivial, right? If the pipeline broke, well, you can just rerun it. If you get weird results, you can rerun it. If you want to try a new feature, just rerun it, perhaps on yesterday's data. You need to backfill, well, just rerun it. And so that psychological impact of being able to rerun things is really important from a development standpoint and a recovery standpoint. And the idea of building a little, testing a little, learned a lot that I learned from my branch chief at NASA in 1990, working in aviation fits here. Iterating on individual parts during development without having to rebuild entire pipelines over and over again is just a much better way to work, I think, because that way you kind of have, you can build a little, make a test, build a little, make a test, build a little, make a test, and pretty soon you've got something pretty rock solid. And then that goes to the other part, the third part of the FITT is tested. For years we've been decorating. The last 15 years I've been in data. I've written, and my teams have written hundreds of thousands of data quality tests. And our customers love it, right? Because, for instance, 7-8 years ago, we had one of our customers say, he loved this. He said, our 10,000 tests didn't catch it. Are you sure you found a problem? And it's a great way to both advertise that you know what you're doing and kind of put the heels back on your business customers when they say this looks weird. And perhaps it is weird, and perhaps the test, you need a 10,001 test to catch it, but a lot of times it just proves how good your system is. And so the idea of FITT is that tests are first-class citizens, and we need all automated tests, no manual testing. And think of tests as the living proof of what the system should do. And you are testing the data, and you're using tests to monitor the tools and the code that are acting upon data. And another one of my favorite phrases that came from Gil, my co-founder, is tests are the gift you give to the future self. Or if you write a bunch of tests, you don't have to own the stuff that you work on for the rest of your career. You can hand it off. And then lastly, another metaphor from an assembly line, the idea of an andon cord, which comes from the Toyota production system in Deming, is that anyone on an assembly line has the ability to stop it by saying, this is wrong. I'm going to pull the cord and stop the assembly line. And that's a good thing, right? You don't want to build something where you know it's going to have an error. And so stop on errors in your production workflow is really, I think, an important aspect. And then what and coverage of tests in the FITT architecture is really important. And this idea that you should shift left in production, i.e. when you get bad data, you should find that data is bad as soon as you possibly can, when it's loaded or the first transformation. Don't let it get to the very end. And then the same thing too, if you can find problems in the new code that you've written on your desktop or in a CI/CD process before it gets to production. Both of these have the 1:10 to 100 scaling issue. If I find problems earlier in production, it takes much less time to deal with your customers after they're yelling at you because the data's wrong. And likewise, if I change some code and I find that really quickly, I'm much faster than fixing it than having that new code get into production and then having your customers up. And so I like the term shift left, shift down because of this T diagram. And so these terms are sometimes overloaded, but this is the way I think of them. And so here's an ad. We have some open source software that since we've written so many tests over our career, we found all the patterns and we put them in a tool that writes 80% of the tests for you, learns your data, and creates all the tests. And it does things like profiling, data set screening. It uses some AI to generate data quality validation tests, does anomaly detection and dashboards. And the point here is that the 20% of the tests that this doesn't do are actually the most valuable thing that you should write. They're unique to your company, unique to the data set that you're using. And nobody writes enough data quality tests. And so our goal is just to give you a tool that writes 80% of them and then has a nice UI so you can manage them. It's totally open source, comes with a UI, full featured, and the enterprise version is pretty inexpensive, $100 per user per month. So now let's go to the second to the last thing, or the last T, two-stage. So what this means is that the whole architecture is set, I start from raw data. And so for us, raw data is immutable. It's not changing to a final data. And that could be process data or the things that are made from process data. And it's sort of, think of it as done in one step. Now, there could be lots of sub-steps. There could be other things that happen, but anything in between, you can throw it out. And so start from raw data, build the whole thing at once. Now, there's some, the question is, when I've talked to this before, the question is, aren't you wasting database cycles? How do you deal with small updates? And so we'll get to those. But this is the main idea. And so in practice with one of our customers, sort of a Fortune 100 company, it works this way. So we've got kind of our software in the middle here. But if you think about it, this first step, there's a data lake that's kind of shared between group one and the corporate entity. And then the two-stage it basically builds a database that's got three layers, raw layers, a star schema, and then sort of a bunch of extract tables that may back up to a Tableau report or may go out to a sales system or whatever. And so this is all sort of built at once in one place. And there's sort of multiple technologies here, some SQL, some Python, et cetera. And again, the data is sort of immutable here in the data lake, but it's addressable by time-based parameters. So sometimes the data is a replacement of data that already exists, or sometimes it's just an update to it. It's here's a week's worth of data. You've got 52 weeks in the database. I've gotten the 53rd week or the 54th week. And so we address it by time-based parameters. And so that's just listing sort of time and location in an S3 bucket. And then what's really good about this is we do parameter-driven builds. So it's super easy to take this whole immutable data set and run today's build, run last week's build, run a development build. And so this idea of parameterization of the process and the two-stage, this is where sort of making it clean is really helpful. And so I'll talk a little bit about that. So my next thing is sort of what I did is I went through what is functional, idempotent, tested, and two-stage. Now we're kind of talk about sort of FITT practices or how to get fit. Sorry for the joke here. So the first thing and how to get fit is parameterization of your pipelines. Right? In our software, our automation software, we get this idea of kitchens and recipes and ingredients. There's another company I like called BioPlan, which actually uses Iceberg and a Python DSL to be able to do that. Again, this is a technique. It's not sort of super proprietary rocket science, right? And think of it this way. In development, I want to use yesterday's data in today's code, right? Where I have these sort of ephemeral hardware environments that I'm spinning up and spinning down. Production is today's data and yesterday's code. And so it's a little more complicated than that, right? You want to be able to sort of, the thing that builds the second step, right? Does all the work. You want to parameterize the whole thing. And so, and create this sort of repeatable process as one orchestratable unit. And so the first thing is like, well, what code am I going to run? Well, let's go here. The first thing you have to think about is what am I going to do? what am I going to do it on, and what kind of sort of metadata I'm going to produce or need. So that could be things like the Git branch, or what data version. So what data am I going to point to? And that's a lot of parameters and dates. The other parts are your credentials, what infrastructure you're going to run on, what database, what tool chain you're going to use. And then you might want to keep track of or point to historic test results, because comparisons between the last time you delivered something and the current time are actually really important. And then maybe operational metadata like notifications, or be able to update a data catalog. So being able to parameterize all this in one step really gives you this cool set of opportunities, because making a development environment, just a couple of parameter changes. Running something in parallel, running a canary version, running one in parallel, again, just a couple of parameter changes. And so this is helpful in a lot of different ways. Like, I have a new data set, I want to run it in parallel with my customer. I have a customer who's got some complicated change, they want to look at it for a week or two. It gives you this nice ability to say yes to customer requests, and with the ability to have this all done in a cloud or in a Kubernetes type environment, it makes it really great to say yes to a customer and then not give the risk of things breaking. And so that's also sort of based on this idea of having multiple environments. And so in the FITT architecture, there really is no environment. There is no dev, no prod. There's just a bunch of parameters that you've run on the environment. And so the environment could be a dev environment, could be a prod environment, could be a A/B comparison production environment, could be whatever you want, right? Canaries are always available. And this, it's gotten a lot easier. 7-8 years ago, we used to do, and you still can do with things like Redshift, a backup and a restore of a database. With Snowflake, it's zero copy clones. Things like Kubernetes, the cloud, it makes it easier. The idea of IAC, infrastructure as code, sort of script-driven stateless environment creation. It's really important to do that. The challenge here is that SQL itself, and most of us do our work in SQL, not in Python. But like, if you think of a chunk of normal everyday SQL, I'm doing an update statement or an alter table. It has side effects, right? I change the table, I update the table. Maybe I install a new SQL component in the database. If my inputs are data, a SQL command, relevant tables, my outputs are change tables, updated tables, and SQL components. And this is the way databases work. It's nothing wrong with that, right? But how do you get FITT techniques when SQL is so not functional and so not idempotent? So the way that we think of it is that it needs an idea of a functional idempotent chunk, for lack of a better word. And think of it as a unit of transformation work. And that work can be executed repeatedly with the same results, regardless of external state. And so there's a set of patterns we follow. Think of it as like create, new, then replace. And of course, in our FITT chunks, they probably should be called FITT chunks. Tests are always included. And what is a build process? It's just a way to run a whole bunch of FITT chunks together, build the entire database and deliverables from immutable raw data. So what does that look like? So think of this as a pattern that we follow. So when we first get the data, we clean up, we set up, maybe we'll take a database table and make a copy of it. Or we'll run a delete, we'll copy, or we'll delete what's there and bring and reload it again. That's another way to do it. And tests. And we'll do our SQL transformations in the window and in the middle, and then we'll kind of do a bunch of cleanups. And so it's these sort of bags on the side of SQL that help us maintain this sort of functional and idempotency of every SQL chunk that we work in. And so this is a practice that we have, and our software helps it a little, but there's also some sort of tribal knowledge that we communicate to our employees to make sure that this happens. And so the real benefit here of this is that I can iterate on a chunk over and over and over again. I can, build a little, test a little, learn as a developer quickly. I'm writing 20 lines of SQL. I write a new test. I run the whole thing again. And of course, everything works in that chunk. And so kind of conceptually, I'd like you to think of these chunks as sort of part of a data pipeline. And so if you look at a typical data pipeline, I set up an environment, I load some data, I test that data, maybe I build some dimensions in a fact table, I test or publish. And however the way you want to do it, data vault, it doesn't quite matter here. In this example, we're just doing a Kimball schema. And so I've got different code using the Python. Maybe I've got some Python that's loading the data. I've got some SQL. I got a DLT. I'm doing some tests in SQL. I've got a bunch of SQL that build my dimensions, a bunch of SQL that builds my fast tables, some tests, and then I got some Python code that publishes it. And of course, we're a huge believer in tests. So every step should have tests. And why? Again, because if something goes wrong, why do everything else? If you can't load the data or you don't have enough data, well, don't do everything the rest and get it to your customer. And so that's the sort of andemic or stop the production. And so we kind of think of these FI chunks kind of fitting into the pipeline, like each piece is a chunk. I can iterate on loading data. And so I don't have to affect anything else. If I have a new data set, I sort of build a new FI chunk, and then I can work that way through the development pipeline. So this is a concept of how we think about doing functional idempotent work in a SQL database that's basically doesn't support functional. And there's some research work that talks about making databases more functional, but it's you can do it. It just takes a little bit of behavior change and thinking. And so there's a pattern that's become popular. And so this is a full build, right? I want to do a full build of a database from raw. And so that's great. And I think you should do it. I think sub 100 terabyte databases, a full build can take 2 hours and cost $10 or $12. I think that's money well spent. And so, for instance, when we do work in our consulting, if someone modifies a FI chunk, we always have them do a full build before they actually check it in to make sure that it all runs. And again, this is yesterday's data with today's code. Again, I can hear you thinking and talking about, well, isn't that expensive in database costs? And I'll get to that at the very end. A pattern of working of doing updates, tested updates, that's gaining popularity is called the write, audit, publish pattern. And it's exactly as I said. You're going to write some data to somewhere else, to a staging table or an audit table. You're going to test it, then you're going to publish it. It's a great pattern for cases where I'm overlaying data. I've got an existing database and I'm adding a couple of hundred rows of new data. I'm updating my Salesforce stuff. And so that process can do that. But if you think about it, it's not necessarily functional and idempotent. So basically I'm saying, make the work that you do a FI chunk and make sure that you do a test on every part. In fact, even after you publish, I run the tests again, just to make sure the publish happened. So, but WAP is great. It's a great pattern, but it's not inherently functional or idempotent. So, apply the FI chunk pattern to that. And kind of going here, some rules of thumb on how to do FITT. So always be able to build completely from raw. Build quality throughout, have tests at every step of the process. And what is done mean for everyone? Done is it's in production. And, when you do have errors, love them. If you have an error in production that you didn't catch, say, great, I'm sorry, we had 800,000 tests that we ran. We're going to have to add a new one to catch that case. And from an ownership standpoint, own the end-to-end pipeline, encompassing both development and production. Like, own everything. And test coverage is very important. And from a manager standpoint, I think you want to drive 2 metrics down, errors and cycle time, and 2 metrics up, productivity and customer satisfaction. And so 2 conclusion slides. So we're going to focus. So your biggest cost is people. So if you want to save money or get more productive with the same amount of money, really that's this area, the people area, is your biggest lever. And so I'm saying, well, this extra cost and doing some more full builds that you normally wouldn't do is going to save so much time on your people that it's going to end up being a benefit. And so I think the other way to think about it is don't overly optimize on compute costs. Yeah, there's opportunities to save, but like doing some more full builds in a FITT architecture is just going to save you so much errors and so much time on your people. And lastly, I think just to conclude this, your data architecture should focus on maximizing data engineer flow and minimizing errors. I think what I've seen with things like medallion architecture, they're all about honestly maximizing data vendor revenues. And while FITT isn't magic, it represents the closest approach we've discovered to making a data engineering kind of boring. Like it's predictable, it's reliable, it's stress-free. And heroism is bad. You don't have to be a hero to make a minor fix. You should be able to hire a 23-year-old right out of school, have them be able to change the name of a table or change the name of a column in your database and have them be able to get in production. They should be able to, and this is why this architecture is really good. They change a column. If you're building two-stage, so you have the complete build, they make a change, they do a complete build, they're going to see the effect of that change in production. They're going to be able to say, I changed a column name. Oh, wow, that messed up how this field was calculated, that broke this report. And they can see that. And I think that's a really good thing for engineers to experience. And that's, if you can have your 23-year-old make small changes on your development team in production and not have to talk to the smartest person and have it, that's really a thing for teams to optimize. And the FITT really helps with that. And then, senior engineers you don't have to keep the whole system in your head, right? They can focus on high value coding and not have to firefight or check everyone's simple, they can just say, did you run all the tests? We'll have another last ad today. We do have some software that we've been using to support this called our automation software. It's kind of built to run the FITT data architecture. It follows data engineers. And it basically does SQL-based DLT. It handles environment creation, deployment automation, these sort of two-step pipelines and testing. And so there's a lot of people who've written about these ideas already around functional programming, around idempotency and data, we've written some much on testing and test coverage. And then we've got 2 articles about FITT that I'd like to reference. And we've got a lot of free resources, including open source software, including data ops certifications and training, testing and certifications and trainings available for you. So that's the presentation today. I'll leave these resources up. Like I said, I'll share the slides and the recording after the meeting. What do people think? Any comments or questions I can answer? All right. Well, thank you, folks. Thanks for taking the time to show. We got through fast today. Give it a try. I think this architecture really focusing on flow, focusing on engineering productivity is what we should do. And this is a very simple way to do things. So thank you much, and have a great day. And look for an email with all the stuff in.